All right, so here we go. First of all, we are going to use the format. I can't remember if I told you this yesterday or not. We are going to use the format for logistic functions, y equals a over 1 plus bc to the x. Did we talk about that? That was kind of the structure that we were going to build our equations in. Now, I want to point out that just like with exponentials, this base can be lots of different numbers, including e. And if you think back to your BFF, the one you memorized, your logistic equation had an e in it, right? They were using a base of e. Doesn't have to be e, it can be anything, so we're going to use this general format and see what we come up with. Now, I don't want to duplicate everything. Did we talk about what the logistic function looks like? Has asymptotes. And the top asymptote, this is what your logistic function looks like. This top asymptote is referred to as the limit to growth. And that vocabulary makes sense, because if you look at the curve, this is actually going up, 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 but there's a ceiling, right? There's that limiting factor. That number is right here. This is your limit to growth. As long as that's a 1, which it's going to be when we write our equations, as long as that's a 1, then this number up here on top will be your limit to growth. So if I told you that the limit to growth is 5, then you already know that your equation has a 5 on top. Oh, can't be mixing up my letters. Okay, so our limit to growth is going to go on the top. Right now, any ideas where I might go from here? There are 3 variables I'm solving for. So it's like a 3-step problem. I do 1 variable at a time. This one's done. It's really easy. It's done. So now I got to focus on finding either B or C. Any ideas how we might proceed? Thinking about what we did with our exponentials? Plug in. I'm going to do that, but not next. That's the last thing I'm going to do. What do I mean by initial value? Does that represent a point? What point does that represent? The initial value. 0, 5/4. Very good. That is your y-intercept. That is where you start. If x is 0, if you have done no multiplying, if you haven't even started doing the problem yet, if x is 0, then this is the value of the function. So remember with your exponential, I had you deal with the 0 point first. That's what we're doing. We're dealing with the 0 point first. Then we'll deal with this one. So I'm going to put in 0, 5/4 right in here. So 5/4 equals 5 over 1 plus bc to the 0. So I'm putting in 0 for x and 5/4 for y. Now, why is that kind of cool? Because this is just 1. So what I really have is 5/4 equals 5 over 1 plus b. How do I solve that? Cross multiply. So 5 plus 5b equals 20. If I cross multiply. And 5b equals 15. And b equals 3. Everybody okay with that? So remember, we had 3 variables. A was right away, we got that one. Now we know B. So now we've got an equation that looks like this. Y equals 5 over 1 plus 3 c to the x. We have found our A and we found our B. So now, Katie, we'll find our C by plugging in the other random point. So what's that gonna look like? 20/79 equals 5 over 1 plus 3 c to the negative second?
Yeah.
Okay, now what? Cross multiply again. So we're gonna have 20 plus 60 c to the negative second equal to 395, maybe. Everybody see how that works? All right, let's subtract 20. So we have 60c to the negative second equal 375. So when I divide and reduce, I get 25/4. Okay. Then what? 1 over c to the second. This means 1 over c to the second. Problem is huge. So 4 equals 25c squared if I cross multiply. C squared equals 4/25. So C equals 2/5. No, we don't do plus or minus because just like with exponentials, the base must be a positive number. Whatever you are raising to the power here has to be positive.
So we're always going to find B first and then we find C after that?
Yeah, because B is going to be found when you plug 0 in because that's going to take the C out.
Okay.
Yeah. So you're always, I erased it now because I needed room, but you're always going to use your initial value point before the other random point. Because it has a 0 in it. So, my final answer after all that messing around, my final answer is y equals 5 over 1 plus, what was B? 3 times 2/5 to the x. And remember, we are never, ever, ever, ever going to multiply the 3 and the 2/5, ever. They're separate numbers. They stay separate. Write them separately. Put them in parentheses, whatever. That was a lot. So let's try one more. There's some like this in your homework. Want to make sure you're able to do it. So let's try one more. So here's the given. The initial value is 25/4. The limit to growth is 10. And we contain the point 3, 50, 29. Okay, so where do we start? Oh, remember, we're writing a logistic function, so this is what we are shooting for. That's what we want to figure out. Okay, So where do I start?
Page 10.
Right from the beginning, I don't even need to show any work, there's no work to show. I can just write that as a 10, and this is done. If you were graphing this, which you're not, but if you were graphing it, you would have your top asymptote. Remember, your logistic function has two asymptotes. Your top asymptote would be at 10. All right, what now?
Plug in the y intercept.
We know that the initial value, even though I've just given you a value there, that's actually the ordered pair, 0, 25/4. So we're going to plug that point into this equation for x and y. So 25/4 equals 10 over 1 plus bc to the 0th. And that is wonderful because c to the 0 is just 1, so I can kind of ignore it. So I have 25/4 equals 10 over 1 plus b. And how do I solve that? Cross multiply. We do a lot of cross multiplying with these. So 25 plus 25b equals 40. So 25b is 15 and b equals 3/5. Good. So our equation is y equals 10 over 1 plus 3/5 c to the x. Just plugging in what I know so far. I got an a value and now I have a b value. All right, now what?
Plug in the point.
Plug in my other point, my random point. So 50/29 equals 10 over 1 plus 3/5 c to the 3rd. Now what? Cross multiply again. So 50 plus 30 c cubed equals 290. So 30 c cubed equals 240. C cubed equals 8. Oh, isn't that lovely? So C equals 2. And after all that, we're going to write in the answer blank, y equals 10 over 1 plus 3/5 times 2 to the x.
So is the cube root of 82?
Cube root of 8 is 2.
Oh, wait.
Okay? All right, let's open up our books now. Let's do a couple different kinds of
Feel around your
problems.
pencil go.
So let's open up our books. And speaking of our books and bringing things to class and being prepared, next week I have to miss a couple of days. So please be prepared with your earphones, headphones, whatever you call them, so that even though I'm not here physically, you can enjoy my presence on your iPad. All right, so make sure you got your headphones with you next week when you come. All right, we are going to look on page 297 at problem number 31. We are on page 297, and we are looking at problem number 31. Now, the problem says right there, this is an exponential growth problem. So I am thinking, and I'm switching gears, because in the problem in red, it says for number 31, exponential growth. So that clues me in that I'm looking at a problem that's going to be set up like this. This is an exponential. We talked about these yesterday. Let's review that for a quick minute, make sure that you're all on track.
What page?
If you had an equation that looked like this, tell me, what does that equation represent? What do those numbers say to me? There's a 7% growth, so this tells me that I have a 7% increase or a 7% growth rate. What else do I know from my equation? 7% growth for sure. What else? The initial value is 100. So whatever we're doing in this problem, whether it's people, 100 people, $100, 100 bacteria, I don't know. Whatever it is, we're starting with 100 of them. And then every time period, whether it's years or months or seconds, it's increasing by 7%. All right, so read problem 31 and build me an equation that looks just like that for problem number 31. What will the equation, don't look at the questions, just look at the problem. What will this equation look like?
Y equals 6,250.
6,250.
And then parentheses, and then maybe 2.75.
Close, but be careful. We don't actually use the 2.75. We have to add it to 1 because we're going more than 100%, right? We're increasing. Remember, whatever your percentage growth or decay is, you either add it to 1 if it's growth, or you subtract it from 1 if it is decay. So a 7% decay would be 0.93. We either add to 1 or we subtract from 1. So you are growing, so it's going to be 1 point, and then whatever the percentage is. So what was it? 2.75? So 2.75% to the x power. Beautifully done. What's the 6,250? That's the initial. When I start counting, that's it. That's what I'm starting with. So there's my initial population. This is my rate of increase. There's my equation. Beautiful. So now I'm ready for the first question. The first question is, estimate the population in 1915. Okay, so what are you going to do? Plug in 1915? You're going to plug in, and it has to do with the 1915.
Subtract the year.
Plug in 25.
Plug in 25. And why would I plug in 25 right here? Because 1915 is 25 years after I started. 6,250 is times 0. So times 0 is 1890. So 1915 is 25 years later than that. Do you see? All right, let's type it in on our calculators. Come on, let's get an answer. Your job is to estimate the population, so that's what you're doing. Typing that in on your calculator. Real easy, nothing hard or fancy, just type it in. Remember, remember to raise to a power, and you use that little button right there, that raises to a power. What'd you come up with? Braden, where's your calculator? Bring it with you.
12,314.
What is it, 12,314?
Well, 15 if you round it up.
12,315. Should Chandler be rounding? Yes, because we're talking about how many people. It doesn't make sense to say 0.83 people or something. That doesn't make any sense. So he rounded off, I think, to the nearest person, and that would be right then. Okay?
How come you don't round down? Because how do you have 0.8 of a person?
You don't have 0.8 of a person. We just
round down
agree to
then?
round to the nearest person. You know, it really isn't worth arguing about. We just generally round to the nearest person. This is an estimate anyway. Chances are that decimal isn't exactly 0.0275, so who knows if it's slightly more than that or slightly less than that, that would impact the answer too. So we'll just round off to the nearest whole person. It's what the grocery store does, or the store does when you when they calculate your tax. They round to whatever the nearest cent is. So it doesn't matter that you haven't quite reached that next cent, they round it up anyway. That's what we're doing. Now, what about the second part of that question? B. Not the second part of question A, but question B. What about that? How are we going to figure out the answer to B? Predict when the population reached 50,000. Now remember, this is your equation. This is the equation you are using for this whole problem. How are we going to figure out when it's 50,000? Katie? We do. Ay, ay, ay. This is a whole new ball game. Any thoughts on how we might proceed? Blakely, what are you doing?
I was gonna divide out 600 or 6,200.
Perfect! That's exactly what you want to do every single time you have a situation like this, and we're gonna have a million of them. A lot of problems end up looking like this. And the first thing you're going to do is divide by 6250. We want to get that number out of here. So what's 50,000 divided by 6250? Oh, that doesn't usually happen, but that's great that we get a nice, neat answer like that. We usually get some weird thing, but that's good. That's good. Now, if this number had been something different than 1.0275, if it, for example, had been something like this, then life would be really good, right? But it's not. It's this awful decimal. How in the world am I going to figure that out? Somebody make Hollis and Ludington really proud. How are we going to figure that out? What? We're going to take the logarithm of both sides. We're not actually going to transform it into its logarithmic form, but we are going to literally take the logarithm of both sides. Now, can you tell me, Alex, why I do that? Okay, there's something really amazing. Anybody remember? Something really awesome happens when you take the logarithm of something to a power. The power actually becomes a coefficient. So in other words, now we have log 8 equal to x log 1.0275. The x, the power, comes out in front. So now, to figure out what x is, all I need to do is divide. log of 8 by the log of 1.0275. Now, if you haven't done any logs in a while, please keep in mind that when you press the log button, most of your calculators are going to put a parentheses right there. Make sure after you type 8 that you close those parentheses before you hit divided by log 1.0275. I'm going to round off to the nearest year. So just to keep it simple, so the nearest year would be how many years? 77. Now I want to make sure though that you answer the question that was asked. The question didn't say in how many years. If it said in how many years, we would say 77 or 76 point whatever it was. But what does the question say? In what year? Okay. So we know we gotta wait 77 years. So how are we gonna figure out in what year it is? Plus 1890. We're starting in 1890, that's our initial value. So what, about 1967? Or since I rounded up, we could say sometime in 1966. Right? Since I rounded up, sometime in the year 1966. Very good. Would you and your partner try number 32 now? It is exactly the same problem, just a different set of given. Would you guys, you and your partner, see if you can come up with problem 32? And I would like these answers and your work put up on the board.
1.02.
So 32A and 32B. Please start by writing your equation. What is your equation going to be?
Y equals 4,200
4,200
times
1.025.
I think it's 2.2. Yeah, it's
2.25?
2.25. Yeah.
Oh, what is it? Yep, 2.25. Very good.
Do you want us to do both years for A?
You don't need to do both years. Just do what was the first one?
30.
30, 1930.
What'd you get? What are your questions?
I got 6,554.
Okay, I need you to put your work up here if you get an answer you're happy with.
Put 1 4. 6,554. We don't round it.
No, we did. I did round it.
No, don't you just do 6,554?
The answer, number A is 4.
Oh, do
Yeah,
you
go ahead and put it up here on the board.
That 20,000 for Y.
Did you get 4.76
Blah blah blah.
divided by or equals 1.025x? And it would build
Okay, Chandler got 6,554 people for the first one. All right, anybody have number 2 or B, part B, I mean? Peyton does, awesome. You just share your work too, sweetie. In case there's somebody out there who doesn't get it.
Where'd you get the 20?
1910.
So what we do log of 4.76 divided by log of that.
Yeah, the 1.022.
This problem changed and we started in 1910. So our initial value, our 0 point was 1910.
I got 2.69.
Okay, remember when you're doing what Peyton's doing, step 1 has got to be dividing by 4,200. You are not going to like what you have to do if you don't divide. You must divide, or it just becomes so much harder. So she divided, now she's taking the log of both sides, she pulls her exponent off.
I got 70 like you.
She's
I didn't
ready to go.
Yeah, it's 70.16. Or just 70, I guess. So what? It being
So she got about 70 years. When did we start this problem? 1910, so the answer would be about 1980. Everybody okay with that? Now, these guys work in reverse also. Take a look, these exponential equations. Take a look at number 40. Number 40 says, the amount of carbon 14, that's just some isotope, that we have after T years is given by this formula. So they're giving you the formula. You don't have to write it. Whoops. Yeah, that's right. Here's the formula. Now the question says, estimate the half-life. What does that even mean? Half-life is the number of years, minutes, second, hours, whatever your time is. It's the amount of time it takes to end up with half of what you started with.
Yeah.
Okay, so we're supposed to find the half-life. So tell me how I'm going to do that here. Half-life is time, so I'm solving for T. What am I going to put in here for C? 1/2 of 20. Exactly. Kids, isn't this number your initial value? That's what I'm starting with. And if I'm starting with 20 and I'm doing half-life, then I need to end up with 10. So I'm going to put a 10 here. Okay. Divide by 20. That's how you do it. Every single time you divide by this number. Now I'm going to take the logarithm of both sides. Now, this is a personal preference. You don't have to do it, but it makes it easier. When I take the logarithm of both sides, I'm going to take the natural logarithm of both sides. Okay? Now, we'll talk about why that's easier in a minute, but I want to get some definitions down. I know you know these already, but I want to make sure I've covered all my bases. LOG, and that's what I had on the board a minute ago, that's what Peyton used, LOG, is the symbol for log base 10. We don't write the 10, we don't need to write the 10, but that's what LOG stands for, log base 10. And those are called common logarithms. So when somebody refers to a common logarithm, they're referring to a base 10 logarithm, which is LOG. ln is a natural logarithm, and it is a base E logarithm. So LOG are called common logs, LNs are called natural logs. So when somebody says to you, let's take the natural logarithm of both sides, that means we are LNing. We're LNing both sides. Now, why would I do that? Well, watch this, and you hopefully you already know because you did these last year. But as soon as I take the logarithm of both sides, this exponent comes out in front. Now, I know it's a big exponent, it's still an exponent, it comes out in front. So off that comes out here in front, so I have that big exponent and then ln e. Okay? Now, this is what I'd like you to look at. Just a quick moment. I know we have more work to do here, but I'd like you just to look at that for a second. On your calculator, type ln e. Now, to ln, obviously the button, just press it, ln. To get e, you actually have to do second ln. And that, now do you have e there? And it's saying what power, so just one, just take it to the first power. And what does that equal? ln e just equals 1. This effectively cancels out. Do you remember that from last year? They cancel each other out. So what you really have, that's gone, so what you really have is t equals the natural log of 0.5 divided by this big decimal. And if memory serves me right, I'm thinking it was 5,700 or 5,400 or something. It's something like that. Tell me if I'm remembering right. 5,700, and that's years. So 5,700 years. Now think back to chemistry for a minute. You have an isotope whose half-life is 5,700 years. Would you consider that stable or unstable?
Stable.
Very stable. It takes it 5,700 years to break down halfway, so it's really stable, right? Now, some elements, you know, or isotopes, have half-lives that are like in minutes or seconds even. Those guys are really unstable, but not this one. Okay, let's try one with our partner. Number 39. Same kind of problem, but it's a growth instead of a decay, but you're going to do about the same exact thing. So try number 39 with your partner. They gave you an equation.
100
No, it should be negative in this one. In B, it's positive, 0.693t. And we want to know when the number of bacteria is going to be 200. So how long does it take to end up with 200 bacteria?
Just put 200 for B.
So you're going to put 200 in for B. That's exactly right. We want to have 200 bacteria. What's step 1? Divide by 100. Please don't forget to divide by 100. Now what?
Take ln each side.
ln both sides. And the beautiful thing is, what happens to the ln e? Gone. So we have ln 2 equals 0.693t. So t equals ln 2 divided by 0.693. What do you come up with? How long is it going to take for this population to double? 1, is it day, hour, what? Hour. It takes 1 hour to double. Any of you ever had food poisoning? That's what they're doing. They're doubling really fast because you're going to get sick really fast if you eat something bad.
It doubles that fast.
Well, I don't know how
So
fast.
do you have to like throw it up before it doubles?
Yeah. different bacteria have different doubling times, but the ones that make you sick are going to double really fast. Okay? Everybody good with this? All right. Now we're going to turn to page number. Oh, we're in the 300s now. Yay! We're going to page 308. And with any luck at all, we are going to crank through problems 1 to 24. They're assigned, so you might want to get a piece of paper out and just get them done. Because I'm sure I assigned 1 to 24. And we're going to fly through these problems.
I look a million on my house.
But before we can fly through them, there is something I must share with you. And you already know it, but you may have forgotten it. A little bit ago, somebody up here in the front said something about writing something in logarithmic form. And actually what I want to talk about now is doing the opposite. It is imperative, this is probably the most important thing I'm going to say all week. It is imperative that you are able to take an expression like this and rewrite it in an exponent format. I'm the teacher. I'm ancient. I do this for a living. I love it. But if somebody throws this problem at me, I cannot interpret it that way. I immediately translate it into an exponent form. The exponent form of this logarithmic expression is b to the y equals x. b to the y equals x. So when I see this problem, my brain immediately thinks 4 to the x equals 16. 4 to the x equals 16. So then I know the answer to the problem is 2. This equals 2. So,
This is Ford.
yep. Yes,
Is Peyton White in your class at this moment?
she actually is.
May I have her to the front office with her charm bracelet, please?
Okay,
Thank you.
It's for volleyball.
okay. That's an unusual one, don't hear that one very often. All right, so let's do one more. Let's say that I saw this problem. I can't do this problem in that form. I don't expect you to be able to. Translate it. This says 3 to the 4th equals x. So the answer to the problem is 81. 81. 3 to the 4th equals x. All right. So with that in mind, we ought to be able to sail through these problems. Log base 4 of 4. I want to know what it equals. So I'm going to put a little equals x on the end. You don't have to, but it helps me kind of think, okay, what does this actually equal? So translating, I would say 4 to the x equals 4. What's the answer to the question? 1. 1. The log base 6 of 1, what does that equal? This is number 2.
0.
Exactly. 6 to the x equals 1. Well, 6 to a power equals 1. The only power that gives you 1 is 0. And in fact, I'm going to write down something special up here. Does it matter if this had been a 7 instead of a 6? No. So in general, the log base b of 1 is always going to be 0. So the log base 7 of 1, the log base 12 of 1, the log base e of 1. Anytime you take the log of 1, you're going to get 0. Okay, that was easy. Okay, the log base 2 of 32. Okay, what's it say? Think about it, what's it say? 2 to the x equals 32. So the answer is 5. So whatever number we're on, 3, that answer is 5. How about number 4? I think I kind of already did that one, but maybe not. The log base 3 of 81. 3 to the x equals 81, so x must equal 4. Oh, 5's a little tricky. Radicals do not live in logarithm land. We do not like to see radicals in logarithm land. So if I don't want to see a cube root, how could I rewrite a cube root?
25
to the 1/3 power. So I'm going to write this as the log base 5 of 25 to the 1/3. When you're doing logs, get rid of your radicals. Write them as fractional exponents. Okay, so now it says 5 to the x equals 25 to the 1/3. Would you agree with that? Don't say x equals 1/3. You can't do that because these don't match, right? So what am I going to have to do? We did it on the quiz we took. We're going to change that 25 into a 5 squared. Right? So what's x?
2/3.
2/3. Yep. X is 2/3. Very good. Number 6 is even trickier. Makes me twitch just writing it. I don't like to have radicals when I have logarithms, okay? So what am I going to do with that 5th root? What is that 5th root going to become?
-1/5.
Well, it's going to become 36 to the 1/5, but it's also 1/, and I don't like that either. So I'll rewrite that, like somebody said out here, 36 to the -1/5. We don't like 1/. So now what?
X, or 6
6 to the x equals 36 to the -1/5. Somebody's got the answer already. What's 36? That's 6 squared. So we have 6 to the x equals 6 squared to the -1/5. So what does x equal? -2/5. Very good. Number 7, log 10 cubed. Don't be confused by that. Don't be confused by that. What's the base here? 10. There's a base there. You just don't see it. So 10 to the x equals 10 cubed. So x equals 3. Now, believe it or not, that's a property. I want you to look back at the original problem and get rid of all these arrows and x's and things. This was the original problem. Log base 10 of 10 cubed. And the answer came out to just be 3. That will happen every time. Remember when your ln and your e canceled out? Well, your log base 10 and your 10 cancel out. So the answer will be 3. So I'm going to add something here. The log base b of b to the n will always be n. Always. Okay, what about 8? What's 10,000? 10,000 is 10 to the 4th. So you have the log base 10 of 10 to the 4th. So the answer to number 8 is just 4. What about number 9? It's log base 10 of 10 to the 5th. So it would just be 5. How about 10? Number 10. Negative 4. Remember, it's the log base 10 of 10 to the negative 4th. That's just negative 4. What about 11? 1/3. Because number 11 is the log base 10 of 10 to the 1/3. So the answer is 1/3. Radicals don't live in logarithm land. Change them to exponents. Ooh, 12 is a little bit trickier. Someone's yawning in the middle of this. I can't even believe it. Here we go, number 12. Here we go. First of all, there aren't any radicals. So I gotta get rid of that and write that as 1,000 to the 1/2. Would you agree with it? I don't like 1/4. 1/4 is hard for me. So I'll rewrite it with a negative exponent. Now, the base here is 10. Can 1,000 be written as a 10? 1,000 is 10 cubed. So you have the log base 10 of 10 cubed to the negative 1/2. This part cancels, and what do we have left? Negative 3/2. Number 13, do not be confused. ln is log base e. So you have log base e of e cubed. What's the answer? 3. What's the answer to 14? Negative 4. Remember, ln is log base e. So you have the log base e of e to the negative 4. That cancels out. The answer is negative 4. This is a property. How about 15? Negative 1. Because you have 1/e, we don't do 1/overs, so we write that as the log base e of e to the negative 1st. How about 16? 0. It doesn't matter what your base is. If you take the log of 1, you're going to get 0 every time. ln1, log 1, log base 12, 1, it's all going to be 0. How about 17? 1/4. We don't do radicals. So we'll think of that 4th root as 1/4 power. And 18 is another tricky one. We got all kinds of problems here. All kinds of problems. First I have a radical, so what am I gonna do with that radical? I'm gonna rewrite it as 1 over e to the 7th to what power? What's the square root?
Sorry, 1/2.
1/2. So this is 1 over e to the 7/2. I don't do 1/overs though. So I'll rewrite that as what? ln e to the negative 7/2. So that's just negative 7/2 because ln is log base e. ln e disappears. Negative 7/2 is your answer. Okay, got those done. Now look at 19 through 24. Those look hard. But if you were just going to take a wild guess, what would you guess the answer to 19 was? If I told you you don't have to show any work, you can look at that problem and tell me the answer. What do you think the answer to 19 is? 3. And it's 3 because you know how your ln and e cancel out? Well, in problem number 19, your 7's cancel out, and the answer is 3. That is another property I'll add to our list. B to the log base b of n is n every time. If these two numbers match, the answer is that number. So what's the answer to number 20? 8. What's the answer to 21? Remember, log is base 10. So the answer would be 0.5. What about 22? 14. What about 23? 6. Remember, ln is log base e. So 6. And what about 24? 1/5? Next time we're together, which we won't be, it'll be my stuff because I don't see you tomorrow, so it'll be Monday. We're gonna have a little quiz, and it won't have 24 questions on it like that, but it'll have a few like that on it. So make sure that you review that a little bit.
You know who the sub's gonna be?
Yeah, Morgan.
Ren?
Oh.
Sweet. I heard he was practicing.
He is practicing.
Is he actually?
I gave him a math
He always
book
says
to
he's a
practice.
mascot.